Hi dear children, today we are going to discuss some initial sections of the chapter Atom. Plum pudding model, alpha particle scattering experiment and Rutherford's nuclear model of atom. In 5th century BC, Democritus, he was a Greek philosopher, gave the idea of atomic view of matter. Then of course before that in 6th century BC, our Kanada, Indian philosopher, gave the same idea. Then electrons were discovered by J.J. Thomson, and at that time we know that electrons are having negative charge and atom is electrically neutral. This two ideas vannu. Electrons were discovered by J.J. Thomson, it is having negative charge. Atom electrically neutral. So there must be corresponding positive charge in the atom to make it as a neutral. So there will be some positive charge, but we are not familiar with the actual structure of the atom and what is responsible for this positive charge. Then in order to explain the structure of atom, the first model was introduced by J.J. Thomson. It is known as plum pudding model or watermelon model. As the name suggests, watermelon flesh and seeds and the same way positive charges in an atom are distributed throughout the atom and negative charges are embedded in it. It was the model suggested by J.J. Thomson. And the positive charge resembles the flesh of that. All over the atom, positive charges are spread out through it. And negative charges are embedded like seeds in it. That's why the name watermelon. Otherwise, plum pudding model, like plums in the pudding. Electrons are distributed like plums in the pudding. It was a model suggested by J.J. Thomson, watermelon model or plum pudding model. Positive charges are present throughout the atom and negative charged electrons are embedded in it. But it was in contrary with the experimental observations. So this model was discarded. And the next very next model was introduced by Rutherford. Actually, he was a research student of J.J. Thomson. And Rutherford introduced the planetary model or the nuclear model of the atom. And actually, he suggested one experiment, that is alpha particle scattering experiment. Remember, he only suggested the experiment and based on his imagination, he made the observations and the conclusions. And he made it in 1906. But in 1911, actually the experiment were performed by two scientists, Geiger and Marsden. And they got the same observations as that of suggested by Rutherford. So before move on to the Rutherford's nuclear model of atom, first we will study about the alpha particle scattering experiment. This experiment is also known as Rutherford's experiment as it is suggested by Rutherford. Also it is known as Geiger-Marsden experiment actually because they performed the experiment. This is the experimental setup for alpha particle scattering experiment. Here there is source of alpha particle which is bismuth atom which is radioactive. So alpha particle will be produced from this. This produce in alpha particle ella direction spread cheyum. So in order to make it as a narrow beam that is passed through lead bricks. We know lead bricks will absorb this alpha particle. So absorb cheyyade or collimated beam aayittu alpha particle it will be passing through thin gold foil. This is very thin of 2.1 into 10 raised to minus 7 meter. Now from this gold foil alpha particle will get scattered in all the directions and the number of alpha particles scattered in different directions can be understood from this rotatable detector. And here this detector consists of zinc sulfide screen and a microscope. So when alpha particle strikes at one position of the zinc sulfide screen, there will be light flashes. ആ നമ്പർ ഓഫ് ലൈറ്റ് ഫ്ലാഷസ് നമുക്ക് ഡിറ്റക്ടറിലൂടെ മൈക്രോസ്കോപ്പിലൂടെ ഒബ്സർവ് ചെയ്യാം. സോ വി ക്യാൻ അണ്ടർസ്റ്റാൻഡ് in which direction different number of alpha particle get scattered. This is the experimental setup for alpha particle scattering experiment. Now observations of the experiment. Most of alpha particles passed straight through gold foil. About 0.14% scatter by more than 1 degree. About 1 alpha particle in every 8,000 deflects by more than 90 degree. A very few alpha particles scattered back in the angle of 180. അതായത് ഓൾമോസ്റ്റ് എല്ലാ ആൽഫ പാർട്ടിക്കിൾസും സ്കാറ്ററിംഗ് ഇല്ലാതെ സ്ട്രെയിറ്റ് ആയിട്ട് കടന്നു പോവുകയാണ് ചെയ്തത്. ആൻഡ് അബൌട്ട് 0.14% scattered by more than 1 degree. And if we take 8,000 alpha particle, അതിലെ 1 alpha particle ആണ് 90 ഡിഗ്രിയിൽ സ്കാറ്റർ ചെയ്തത്. And a very few alpha particle scattered back into the same direction in 180 degree. These are the observations of this alpha particle scattering experiment. Now remember this, the number of alpha particles scattered per unit area at scattering angle theta is inversely proportional to the fourth power of sine of angle divided by 2. This is the graph corresponding to the number of alpha particles scattered at various angle. Now conclusions of the experiment. As from the observation, most of the alpha particle passed without scattering. We can conclude that most of the space of the atom will be empty. അതുകൊണ്ടാണ് സ്കാറ്ററിംഗ് ഇല്ലാതെ ആൽഫ പാർട്ടിക്കിൾസിന് ഫ്രീ ആയിട്ട് കടന്നു പോകാനായിട്ട് സാധിച്ചത്. Now second one, a very few scattered back in 180 degree. So from that we can conclude that positive charge and almost all the mass of the atom is concentrated in a very tiny central core. ആ സെൻട്രൽ കോറിനെയാണ് ന്യൂക്ലിയസ് എന്ന് പറയുന്നത്. അതിൻ്റെ ആറ്റത്തിൻ്റെ ഓൾമോസ്റ്റ് എല്ലാ മാസും പോസിറ്റീവ് ചാർജും ഈ സെൻട്രൽ കോറായ ന്യൂക്ലിയസിലാണ് സിറ്റുവേറ്റ് ചെയ്തിരിക്കുന്നത്. ആൻഡ് അനദർ വൺ ഹിയർ the force responsible for this scattering is the electrostatic force of repulsion between the positive charge of alpha particle and the positive charge of the nucleus. നമുക്കറിയാം alpha particle is the nucleus of helium, so it is having positive charge. At that time it was unknown, but alpha particle is having positive charge. Nucleus is also having positive charge. This positive and positive will repel. ഈ റിപ്പൽഷൻ മൂലമാണ് വരുന്ന ആൽഫ പാർട്ടിക്കിൾ സ്കാറ്റർ ചെയ്ത് പോകുന്നത്. Now we can summarize the conclusions of alpha particle scattering experiment. Atom has lot of empty space. The positive charge and most of its mass is confined to an extremely small central core called nucleus of the atom. Scattering of alpha particle is due to the electrostatic force of repulsion between positive charge of nucleus and alpha particle. Now